In this video, I want to work through 3 examples of solving literal equations that will require factoring in order to isolate the variable. So remember, a literal equation is just going to be any equation that has more than one variable involved. And so in this literal equation, we have both a and b, and we're going to solve for a. And you'll notice here, one of these terms is just 4a, but one of the terms is 3ab. So to isolate that a, we're going to have to do a little something extra. Well, let's go ahead and get all the terms that have an a on one side. Let's put them on the left side. And all the terms that don't have an a, let's put those on the right side. So to start this, we'll subtract 3ab from both sides of the equation. And we'll go ahead and add 3 as well. So you can see a few things are going to happen. Those 3's will cancel, and of course the 3ab's will cancel. And it'll look like this. So we have 4a minus 3ab, and that will equal negative b squared plus 3, or let's go ahead and sneak that 3 in front and say 3 minus b squared. So instead of having a leading negative, we can hide that kind of in the middle as a subtraction. Well, okay. Well, we're trying to isolate this a, and we have an a here and an a here. So what we're going to do is factor that a out of this binomial, so the two terms. So basically, we're going to do the backwards distributive property. So we'll be taking the a out. So let's take that a out here, and when we divide the first term by a, it looks like we'll just have 4. And when we divide the second term by a, it'll look like we have negative 3b. And the rest of that right side will just come along for the ride. Now we have this a in such a position where we can do a little division and we can isolate that a. And it was made possible by factoring that a out of both of these terms. So we have a times this expression right here, 4 minus 3b. So let's go ahead and divide both sides of this equation by that 4 minus 3b. On the left, of course, they'll cancel, and you'll be left with just a. And on the right, we'll have this fraction. So 3 minus b squared over 4 minus 3b. And looking at this right side, nothing will cancel. Because remember, when you have a fraction, in order to cancel anything, you have to factor out common factors first, and then you can cancel any factors that may be the same, just like simplifying fractions. So in this case, we can't simplify it anymore, but we have isolated our a variable. So we set out to solve for a, and we did just that. In this example, we have ourselves a nice proportion. We have this fraction equaling this fraction. We're going to work this twice. The first time we're going to solve for x, and the second time we're going to solve for y. And we're just going to take a look at the relationship between those two variables and kind of the process. So because we have a nice proportion, we will do cross products and we'll set them equal to each other. And because a lot of these look like binomials, two terms, we need to make sure we put parentheses around them during the multiplication process. So let's start with this one. So we have 6y, and we're going to multiply that by the x plus 6. So we make sure to put that x plus 6 in parentheses. And that will equal, and we have these two binomials, so y minus 5 multiplied by x minus 4. And once again, we're solving for x this first time. So it looks like we've got some multiplication to do. So we'll go ahead and distribute here, and we'll FOIL this out or multiply these two binomials, kind of however you're familiar or comfortable with kind of talking about that. So this first one looks like 6xy plus 36y whenever we distribute. And this right side looks like xy minus 4y minus 5x plus 20. So since we're solving for x, we need to get all those terms that include an x on one side, preferably maybe the left side, and then we'll get all the non-x terms on the right side. So here's a term with x, and here's a term with x, and here's a term with x. So we'll just take this guy and kind of push him over to the left side. We'll do that by subtracting xy and adding 5x. So we'll do that by subtracting xy and adding 5x. And then those cancel. And then we'll take this positive 36y and move him over to the right as a negative 36y. So we have this minus 4y, the plus 20, and the minus 36y. And once again, you can take a term from one side of the equation to the other side of the equation simply by changing its sign. So change sides, change signs. So solving for x here, it looks like we have some like terms we can combine on either side. So 6xy minus xy will give us 5xy, and then plus that 5x. And then here it looks like we can do 20 minus 40y. All right, well, here's an x and here's an x. And once again, we see that we have two terms, and they're not like terms, but they do both include an x. So we need to factor that x out, and so we'll do a little backwards distributive property. And once we have this x on the outside, we'll divide x out of each of these terms. So it looks like 5y plus 5 will equal that 20 minus 40y. And the next thing to do, because x is being multiplied by this expression, we will just take both sides of this equation and divide it by that 5y plus 5. So of course on the left we'll see those 5y plus 5y terms cancel, 5y plus 5 terms will cancel. So we have x equals 20 minus 40y over 5y plus 5. Well, interestingly enough, it looks like every single term on this right side has a 5 in it. So what we're going to do is factor a 5 out of both the numerator and the denominator. So when we do that to the numerator, it looks like we have, what, 4 minus 8y. And in the denominator, it looks like we have y plus 1. So what we can do is cancel those 5s, and that's kind of what I was discussing in that previous example. You can't cancel anything from numerator to denominator unless you factor first and then cancel like factors. All right, so now we see in this case that x is going to be this fraction 4 minus 8y over y plus 1. So that's what that looks like whenever we solve this proportion for x. So let's go ahead and revisit this example again. We still have our proportion here, this fraction equaling this fraction. But this time let's go ahead and go through and solve for y instead of x. So I'll do this part fairly quickly because we've already discussed it. So let's do these cross products. Looks like 6xy plus 36y. When I multiply xy minus 4y minus 5x plus 20 right there. Okie dokie, so solving for y this time, we see there's a y here, and here, and here, and here. Lots of y's. So the negative 5x plus 20, he'll just stay over here on the right side. And let's go ahead and get these two terms that included y's. Let's go ahead and move them over to the left side. So we'll subtract xy and add 4y. And cancel and cancel. So we have 5xy plus 40y equals, and let's go ahead and push this 20 in front of the negative 5x. That way we don't lead with a negative. We can kind of hide that negative in the middle as a subtraction sign. So solving for y now, we see on this left side we have two distinct terms. One is an xy term and one is just a y term. So they're not like terms. I can't combine them. But remember what we did in order to get this y by itself, we need to first factor it out. So we'll take this y out front and it'll be backwards distributive property. So we will undistribute it, if you will. So we'll divide out of both of those and we'll have 5x plus 40 is what it looks like. And that will equal that 20 minus 5x. So since we have this y being multiplied by this expression, we can go ahead and divide both sides by that 5x plus 40 expression. And when we do that, on the left side, of course, they will cancel, leaving our y isolated all by itself. That's exactly what we like. And on the right side, we'll see 20 minus 5x over this 5x plus 40. And just like we saw in the previous example when we worked at solving for x, you'll notice there's a 5 in every single term. So let's go ahead and factor a 5 out. So we'll have 4 minus x over, and then 5 times, it looks like x plus 8. And what will happen here is these 5s will cancel, And y then will equal 4 minus x over x plus 8. And that is that same example solving for y in this case. So let me go ahead and rewrite when we had the x equals, and it was 4 minus 8y over y plus 1. This is what we had the first time we walked through it. So you'll see in the left one we have y isolated, and in the right one we have x isolated. And there's a lot of similarities between these two answers. You'll see that we have the 4 minus x, we have a 4 here and a 4 here, and an 8 down here, and an 8 up here, and a couple of x's here and a couple of y's here. So you'll see a lot of similarities like this whenever you're solving these literal equations, but perhaps maybe you're solving for a different variable each time, like we did here. We solved for x the first time and y the second time. Anyway, that's how we can do that. We had this nice proportion, we used cross products, and we isolated that variable. So here in this third and final example, we have a bit longer of an equation here, and we have both x's and y's, and we would like to solve for y. And I think here at the end we'll see something interesting. So of course let's start by distributing and getting rid of all these parentheses. And it looks like on this last one we're just going to be distributing a -1 through here. So let's go ahead and do that. So we have y plus 1 minus 6x minus 4xy it looks like. And then 2x minus 4 minus y plus 1. So again, solving for y, and it looks like we have some things that can cancel. We have a positive 1 here and a positive 1 here. So if we were to subtract 1 from both sides, those terms would automatically cancel. So we can start by doing that. Here's a term with a y, and here's a term with a y, and here's a term with a y. So let's go ahead and get all those terms with y's on one side, and we'll do it on the left side, was what we're kind of collect those terms. So this is a negative y, so we'll go ahead and add y to both sides, and I'll put it here. So those will cancel. And then similarly, this guy does not have a y, so we'll add 6x to both sides. And it's nice because in both cases, I was able to line up some like terms. So let's see what we have here. It looks like y plus y is 2y, and then minus 4xy, and that will equal 8x, and then let's see, -4. So just like that. So far it looks a lot like the previous problems we did. We have a y here and a y here. Once again, they're not like terms, so I cannot combine them. So I'll have to factor the y out. So when I do that, I'll divide y out of both of these terms. So it looks like I'll have 2 minus 4x, and that will equal, of course, that right side, 8x minus 4. And this y is being multiplied by this expression, so we'll divide both sides by 2 minus 4x. And so far, nothing interesting. But now that we have y equals, looks like we have 8x minus 4 over 2 minus 4x. So in these terms, it looks like I have a 2 that I could factor out and maybe cancel. But look for a moment, if you will, a little closer. It looks like this is an x minus a constant, and then here we have a constant minus an x. So let's factor maybe the 4 out of the top, and so we'll have 2x minus 1. And instead of factoring a 2, let's factor a -2 out, and there's a reason. I want to show you this. So if we factor a -2 out, this 2 will be a -1, and this minus 4x will be a positive 2x. So what does that look like now? Well, I'm going to rewrite that term in the denominator as -2, and I'm just going to switch the order there. So 2x minus 1. Hey, look at that. So the 2x minus 1's actually cancel out. And then we have 4 over this -2, so we can cancel a 2 out of each one of those. So it looks like I'll have y equals a -2. So y equals -2. And one quick thing we can say if you've studied domains or values that are undefined, that kind of thing, because we canceled out this 2x minus 1, you could add the provision here that x cannot equal 1/2. And if you haven't studied about that yet, that's okay. You don't necessarily have to write that. But here's what we have. Y is -2. So in this example, it seemed like we had a much longer equation, lots of terms. We went ahead and worked it the same exact way, but we had a little bit of an interesting thing happen where all the x's canceled, and I was left with just y equals -2.